this video, we are going to focus on revision for Chapter 3, Periodic Table, and also Chapter 4, Chemical Bonding. Look at this question. The position of an element in the periodic table is determined by its proton number. Question number 2. Which of the following can form isoelectronic configuration? Isoelectronic have the meaning of same number of electrons. Okay, so the answer will be A. N3 negative, nitrogen basically have 7 plus 3, oxygen 8 plus 2, neon 10, magnesium 12 minus 2. So all of these have 10 electrons. Next question, number 3. Choose the factor that will affect the magnitude of the ionization energy. Basically, we know the signs will affect the ionization energy. But then what are the factors that will affect the signs? Is either effective nuclear charge or the shielding effect. So in this case, another term for shielding effect also can known as screening effect. Shielding effect also is a factor. Effective nuclear charge also the factor. So the answer will be all the above. The ion that is isoelectronic with argon. So again, argon have 18 electrons. So iso means that they have same number of electrons with argon. Fluorine proton number is 9. 9 plus 1 equal to 10. Sodium 11 minus 1 equal to 10. Sulfur 16 plus 2 equal to 18. So the answer is C. Question number 5. Which one have the highest second ionization energy? So from here we will know that the second electron is either removed from inner shell or half-filled orbital or full-filled orbital. Okay, because half-filled and full-filled orbital have extra stability. While for the inner shell, the attraction between nucleus and valence electron becomes stronger. So from here, we will choose sodium because sodium is element in group 1. So second electron will be from the inner shell. Okay. Across period 3, what will happen to the element? First, the oxide of element become more acidic. Yes, correct. Because as we know, metal oxide always is basic. So, and then across the period from metal will become non-metal. So means that it is more acidic. Question 7 are given us successive IE. So basically we will get the idea. We need to look for the sudden increase. So the sudden increase is happened at here, which is actually involve the 5th and 6th electron. So from this data, we know that the 6th electron is from inner shell. So means that this element is group 15. So if this element is group 15, means that it is in P block element. Which of the following pair compound are only acidic oxide? So just now we already discussed, if acidic oxide, normally they will involve non-metal. So when we look at here, sulfur and chlorine are non-metal. So the answer is D. Proton number for chlorine, potassium, calcium are given 17, 19, and 20. Then we need to find out the ionic radius increasing size. So that means from the smaller size to the bigger size. So when we check at here, all these ions, they are isoelectronic species. So if they are isoelectronic species, the factor that we are going to consider is effective nuclear charge. So let's find out what is the effective nuclear charge for Cl negative. 17 minus 10, positive 7. For the K plus potassium ion is 19 minus 10, positive 9. Calcium is 20 minus 10, positive 10. So from here, the biggest, the effective nuclear charge, the smallest the size. So that's why calcium 2 plus has the smaller size and then Cl negative has the bigger size. The answer is B. Question 10. We are given the proton number and then we are going to arrange atomic radius. So based on the proton number, we may write down the electron configuration. We can use simple way to write the electron configuration. 2, 6, 2, 7, 2, 8, 1, 2, 8, 3. So generally, T and U have bigger size compared to R and S. Smaller. Okay, then between T and U, which one have the bigger size across the period? Okay, T is over here, U is over here. Across the period, the size is getting smaller. Okay, so means that the bigger size is T, so the answer is either B or C. Okay, so the arrangement for the third element is correct, so then now we need to check R and S. Okay, R and S is over here, group R comes first and then S. As we know that S has the, across the period, the size is getting smaller, so S is the smaller size. So S supposedly and the smallest is C. So the answer is this one. This is the electronic configuration for an atom, and then the question asks us to look for the number of electron. Means that we are going to total up the number over here. So 1s2 until 2p6 is 10 electron, 3s2, 3p6, 4s2, another 10 electron, and then d5 is another 5 electron. So total is 25 electron. Next question, 1s2, 2s2, 2p6. This is the electron configuration, and then we are going to ask to look for the period and also the group. Since the highest energy level n is equal to 2, so means that it is period 2. So answer B and D will be out. And then if you want to know the group, we are going to look for the number of valence electron. So which is 2 plus 4, because it is p block element, so we add 10. So total is 16. So the answer is A. Next question, which one is the correct statement when we compare the size of aluminium atom with the aluminium ion? So as we know, cation produced when the electron is removed. So when the electron is removed, the remaining electron will be more attracted to nucleus. So once it is more attracted to the nucleus, the size will getting smaller. Okay, so the answer for B will be out. The answer for D also will be out. Okay, so then the explanation already here. So based on the answer and the explanation, answer will be A. Which of the element has the highest first ionization energy? So like just now we already mentioned, if there is sudden highest ionization energy, it's either it is from inner shell or the electron is removed from half field orbital or full field orbital. So in this case, the answer will be phosphorus, because phosphorus is element in group 15. So 1s2, period 3, 2s2, 2p6, 3s2, 3p3. So 3p3 show that the p orbital is half filled, so that's why the first ionization energy is the highest. Question 15. Across the period, the size is decreased because of the proton number increase, cause the effective nuclear charge also increase. When the effective nuclear charge increase, attraction nucleus and valence electron become stronger. Therefore, valence electron nearer to nucleus, and then the size will getting smaller. So from here, the answer will be B. Total valence electron for phosphonium ion. Phosphorus has 5 valence electron, hydrogen has 1 valence electron, but we have 4 hydrogen. Negative charge means lose electron, so we are going to minus 1. So 5 plus 4 minus 1 is 8 valence electron. The answer is A. What is the molecular geometry for PF5? Phosphorus 5 valence electron, fluorine 7 valence electron times 5. So all together over here we have 40 valence electron. Okay. Then when we look at here, there are 5 terminal atom. So divide by 8 equal to 5. So means that PF5 has no lone pair electron. So we only have 5 electron domain. So the basic shape for 5 electron domain is trigonal bipyramidal. Next question, which of the following diatomic has the strongest covalent bond? So we have 3 types of covalent bond. Basically we have 2 ways to check about covalent bond. Either it's based on polarity, polar or non-polar, but generally all here have similar atom, so means that they are non-polar molecule. So if we are not focused on the polarity, then we are going to focus on the single bond, double bond, and also triple bond. Among this single, double, and triple bond is the strongest. So then we know that nitrogen, this is the Lewis structure for nitrogen and consists of triple bond. So nitrogen has the strongest covalent bond. KF4 is shown as below. So based on this Lewis structure, we are going to know there are 4 terminal atoms. Each terminal atom is going to achieve octet, so 4 times 8, and then have lone pair electron plus 2, so total is 34 valence electron are shown in the Lewis structure. But then we have this idea of fluorine has 7 valence electrons, so we have 4 valence, we have 4 fluorine, so 4 times 7 means 28 minus 28 valence electron, which are from fluorine. So that means remaining 6 valence electron are from A. So if they have 6 valence electron, means that A is element from group 16. So carbon is element from group 14, phosphorus group 15, silicon also 14, so sulfur is group 16. So the answer is sulfur. Which of the combination will form ionic bond? So as we know, ionic bond is formed between metal and non-metal. So basically, carbon and chlorine will be out, sulfur and oxygen will be out as well, because both of them are non-metal with non-metal. So boron is metal, fluoride is non-metal. However, this one also will not form ionic compound, but they will form ionic compound. So do keep in mind that there are few elements like beryllium, boron, and also aluminium. They have tendency to form covalent compound due to their small size and also high charge. So in this case, potassium and bromide will form ionic bond. What is the formal charge for iodine? So we need to draw the Lewis structure. Iodine has 7 valence electron. Chlorine also has 7 valence electron. So total we have 28 valence electron. Iodine with 3 chlorine. So each chlorine going to achieve octet. So 8 times 3 minus 24. So we have extra 4 electrons, which we're going to place at the iodine central atom. So then if now we want to calculate the formal charge, the number of valence electron for iodine is 7, number of bonds is 3, and then minus the lone pair electron is unpaired electron is 4, so total is equal to 0. So the formal charge for iodine is 0. Which of the following bond is most polar? So if it is most polar, means that the difference of electron negativity is the biggest. So we just like do mathematics. Oxygen 3.5 with 4.0, so the difference is 0.5. Chlorine is 3, hydrogen is 2.1, so the difference is 0.9. Carbon is 2.5, fluorine is 4, difference is 1.5. Fluorine is 4, and then another also 4, so the difference is 0. So from this simple calculation, we know that the answer is the C. Which statement is correct for the hydrogen bonding? Except. So that's means we are looking for not true. Okay. Ethanol can form hydrogen bond, therefore it can dissolve in water because water also have hydrogen bond. So this is correct. Hydrogen bond is stronger than van der Waals force, correct as well. Hydrogen bond can form between polar molecule. This is not correct, not necessary. But a compound with hydrogen bond automatically will consider as polar molecule. But polar molecule not necessarily consists of hydrogen bond. For example, HCl, this one is polar molecule, but they cannot form hydrogen bond. Okay, so that's why not all the polar molecule has hydrogen bond. But molecule with hydrogen bond basically are polar molecule. So, and then hydrogen bond is one type of the intermolecular force. Which of the following is polar molecule? So basically, polar molecule is the one with symmetries but different terminal atom. Okay, or compound with lone pair electron, but not square planar. Okay, so when we draw the CH4, we already know this is the Lewis structure for CH4. There has no lone pair electron and then it is symmetry. So this is non-polar molecule. SF4, sulfur has 6 valence electron. Fluorine has 7 valence electron times 4. 7 times 4, 28. So total is 34. But then we have 4 fluorine terminal atom. We minus each of them, we're going to achieve octet. So 8 times 4, 32 equal to 2. So that is lone pair electron. So the answer is B. Choose the correct sequence for the decreasing strength of intermolecular force. So for the sulfur dioxide, we know sulfur has 6 valence electron. Oxygen also has 6 valence electron. So 6 times 3 equal to 18. And then minus 2 terminal atom, 16. So 6 times 3 equal to 18. And then we minus 16, we have 2 electrons. So compound with the lone pair electron, we consider this one is polar molecule. While for the fluorine is non-polar molecule. And then for CH3OH, they are polar molecule and then they consist of hydrogen bond. So non-polar molecule only consists of London forces. And then SO2, even they are polar molecule, but they cannot form hydrogen bond. So the most significant intermolecular force is dipole-dipole. So among all these 3 types of intermolecular force, hydrogen bond is the strongest, followed by dipole-dipole, and then the weakest is the London forces. So the answer is Dopke. Lewis structure of CH4 are given with 4 electron domain, so means that they are supposedly in the tetrahedral shape. So and then the question is asked us about the bond angle. So the bond angle for tetrahedral shape is 109.5. 107 is the bond angle for ammonia, and 104.5 is the bond angle for water. Okay, this question, when we look at the answer here, incomplete expanded octet, then we will know that we are going to focus on the central atom. So we calculate the total number that surrounded the central atom is 2, 4, 6, 8, and 10. So 10 electron, so means that it is not a chief octet and also not incomplete octet. The answer is expanded octet because more than 8 electrons. Question 13. Which of the following is polar molecule? So again, we are going to draw the Lewis structure and check which has the lone pair electron generally. So we may try with the Dopke. Phosphorus has 5 valence electron, and then hydrogen have 1 valence electron times 3. Total have 8 electrons. So phosphorus with 3 hydrogen, so means we are going to minus 6 and then have extra 2 electrons. So going to put at the central atom. So with lone pair electron, pH 3 will be considered as polar molecule. Okay, next question, type of bond. If we can see that there is C of delocalized electron with positive ion or cation, so this is the definition for metallic bond. Last question, which of the following species have dative covalent bond? So I think generally most of us already have idea. The dative compound or element or the ion with the dative covalent bond is NH4+, H3O+, Al2, Cl6, BF3, Okay, these are the 4 very common compound or ion with the dative covalent bond. So in this case, the answer is B. So that's all for this revision. So hopefully you get some idea from here, and then we'll see you in next video again. Thank you.